Okay, just let's answer this question two different ways. If we disconnect bolt B, does F get brighter or fainter? Okay, now what we have here, what the battery sees, it sees light bulb F in series with 3 light bulbs in parallel and 2 light bulbs in parallel. Now the overall resistance that it's going to see, it's going to be the resistance of F plus something smaller than the resistance of F, because 3 resistors in parallel are going to have a smaller resistance than any one of them. And then something also smaller than F, that's the resistance of both A and B. So the overall resistance that the battery is going to see is going to be a little bit less than twice the resistance of F. Now, if we disconnect B, what the battery is going to see is going to be F plus these 3 in parallel, which are again a smaller resistance, but then plus A. The resistance of A is the same as the resistance of F. So the battery now is going to see more resistance, twice the resistance of F plus something smaller. So it's going to see a bigger resistance, meaning it's going to, the current that's going to flow is going to be smaller. If the current is going to be smaller, then the light bulb is going to be fainter. Let's try to explain this quantitatively. Because I have 2 and 3 here, I'm going to use the common denominator. Let's use 6. 6 for the let's assume that all light bulbs have a resistance of 6 ohms. 2 resistors in parallel are going to have a resistance, since they are equal, a resistance that's going to be half as much as each one of them. So RAB is going to be 6 ohms over 2, so 3 ohms. And then RCDE is going to be the 3 in parallel, so if you calculate it, you should find 6 ohms over 3, that's 2 ohms. So the overall resistance seen by the battery is going to be 6 ohms, that's the resistance of F, plus 2 ohms, that's the resistance of RCDE, plus 3 ohms, that's the resistance of AB. So it's going to see a resistance that's equal to 11 ohms. Okay, now let's see, what if we disconnect B? If we disconnect B, it's going to see here RA. So it's going to see the resistance of F, that's 6 ohms, resistance of RCDE, that's 2 ohms, plus the resistance of A, that's 6 ohms. It's going to see a resistance of 14 ohms. It's a bigger resistance, so the current that it's going to draw from the battery is going to be less. Current is less than the power dissipated by the light bulb, since it is Ri squared, less current, so it's going to be less bright. Okay. Now let's answer this one here quantitatively. The battery is 5.5 volts and each bulb is 6 ohms. Find the current through each of the bulbs and the power dissipated by each of the bulbs. Okay, now from what we have just done a minute ago, we know the resistance RCDE, that's equal to 2 ohms. RAB, we said that's equal to 3 ohms. So the overall resistance RABCDEF, we calculated it before as 11 ohms. So my battery is going to see just a resistance, my My circuit is going to look like this. Plus, minus, plus, and then 11 ohms. So the voltage across the 11 ohms is 5.5 volts, and it's going to be equal to 11 ohms times I. So this way I can find the current through the equivalent resistance, 5.5 volts over 11 ohms, which is 0.5 amps. That's the same as the current through the resistance F, or light bulb F. So for F, the power dissipated is going to be R of F times I squared. So it's going to be 6 ohms times 0.5 amp squared, which is 1.5 watts. Okay, now for resistors A and B, since they are in parallel, they are going to share the current 2.5 amps. So IA is going to be 0.5 amps over 2, or 0.25 amps. So the power at A is going to be the resistance of A, which is 6 ohms, times 0.25 amps squared, which is going to be 0.375 watt. Now, the current through C is going to be the third of the current through F, because the current is going to be divided equally among these three branches. So that's going to be 0.5 amp over 3. Now the power then is going to be power at C, which is going to be 6 ohms times 0.5 over 3 squared. And that should be equal 0.17 watt.